So, good afternoon, all of you. We were saying in the last class that what is electric dipole? An electric dipole is a system of two equal charges but opposite in nature, separated by a finite distance. And that distance is called what? Dipole length. So here the dipole length, by convention, we write 2a. Why? Because we have the dipole center. And whenever we want to measure a distance from a dipole, which is not from this Q and not from this Q, it is from the center of the dipole. Let's say I need to find a distance at here. So this R will be measured from the center of the dipole and not from any of the charges. So this is the electric dipole. Then we have direction of electric dipole. What is the direction? In the last class, we have seen that the direction is from the negative charge to the positive charge. In the physics, it is the convention that the direction of electric dipole is from the negative charge to the positive charge. Now just pay attention. What is electric dipole? Where we can find an electric dipole? Okay, let us say I have a molecule. Well, it's an atom of hydrogen. Hydrogen atom has a single electron. Let's say I have atom of chlorine. What is the atomic number of hydrogen? It is 1. What is the atomic number of chlorine? It is 17. Where two equal and opposite charges are found. Okay, good. This is the dipole axis and this is the equatorial axis, which we have studied in the last class. It is equatorial axis and it is dipole axis. So I was saying that the atomic number is 17, which means number of electron in the chlorine will be 17. So if I need to say that the electronic configuration, chlorine has maximum electron negativity. So it has maximum electron negativity, which means it has tendency to attract the electron. So if it has tendency to attract the electron, then here the electron will leave positivity. And if electron is coming from here to chlorine, it will create negativity here. Okay. Magnitude of this positivity will be equal to this negativity. So I can say that it is nothing but a dipole. A dipole. But in the chemistry, the direction of the dipole is from positive to negative. Direction of the dipole is from positive to negative, but by convention, we say in the physics, the direction of the dipole is from negative to positive. So, or else, let's say I have a uniform electric field. Okay, and a dielectric is placed between the electric field. So if a dielectric is here, the electrons will experience a force. What is that force? Electrostatic force. The electrons will experience an electrostatic force in this direction. So negative charges will be, okay, electrons will be experienced, since the electron is negative charge, so they will experience the force in this direction, since the electron is having negative charge. So due to that, this part of this dielectric will consist negativity, and since the electron has placed here, so they will leave here the same magnitude of positivity. So it is nothing but a electric dipole. So if I say, what can you say about this distance? Okay, what is this distance? It is very, very, very less. Sir, please repeat again. What I need to repeat again? You know what is electric dipole? Do I need to repeat how the HCl became a dipole? Okay. Hydrogen has 1 electron. Chlorine has maximum electron negativity, which means chlorine has the tendency to attract the electron. So if it will attract the electron, this terminal will be the negative charge, negatively charged, and this terminal will be positively charged. But the magnitude will be same because these electrons have been transferred here only. That is why it will be negative and it will be positive. Magnitude will be same but opposite in the nature. Okay. So that is why this has become the dipole. But now my concern is about what is this distance? This distance is very, very less. So if due to this dipole, I want to find electric field or potential or anything at this point, then let's say this is the R, this is R. So if this is R and this is what? 2A, then I can say that 2A is very, very less than R. I can say that we will use this expression in the derivations. That is why I was telling you. Okay. We have an equatorial axis and a coaxial or else the axis of the dipole. Now the next thing is dipole moment. What is dipole moment? Anyone? What is dipole moment? Very good. Q into 2L. But what is Q? What is QL? In the language, we'll say that dipole moment P is the multiplication of magnitude of either of the charge with the separation of charge. What is the magnitude of either of the charge? It is same. But what is the magnitude? It is Q. Q is the magnitude. What is the separation? Separation is 2A. So we get P is equal to Q into 2A or else 2QA. This moment is a vector quantity. This moment is vector quantity. But this charge is what? It is scalar. Which means to make this moment a vector quantity, this 2A should be treated as a vector. What is 2A? It is length, or length vector kab hoga? When this length is nothing but the displacement. Getting my point? When this length is nothing but the displacement, we can say that this moment will be a vector quantity. Okay? What is the unit of the dipole moment? For charge, it is coulomb. For length, it is meter. So the unit of dipole moment will be coulomb meter. Okay? It is the SI unit. The SI unit of dipole moment is coulomb meter. There is a non-SI unit also, and we call it dBi. dBi. So 1 dBi consists of how much coulomb meter? It is 1 dBi is equal to 3.3 into 10 to the power minus 30 coulomb meter. You should remember that. Okay? This much is clear. Dipole moment is clear to everyone. Okay. Then let's do a question. We have placed 3 charges. Well, it is, let's say, minus 2q and plus q and plus q on an equilateral triangle. Equilateral triangle having each side is equal to A. Okay? And you need to find out the dipole moment. Since the dipole moment is the vector quantity, तो आप क्या कर सकते हैं? Want to give it a try? Okay, try once. Okay, very good. I have minus 2q plus q and plus q, but this is not a dipole. So let's make this picture clear. I can write this as minus q and minus q, 2 minus q, and here plus q, here plus q. This dipole length is A, this dipole length is A, this separation is A. So I can say that this is a dipole minus q plus q, and this is another dipole minus q plus q. What will be the direction? It will be minus q2 plus q. It will be minus q2 plus q. Let's say it is P1 and it is P2. Okay? So let us solve this. I have P1 in this direction. I have P2 in this direction. What is P1? It is Q into separation of charges. What is the charge? Q. So P1 will be what? Q into A, not 2A, because here 2A is what? A. That is why separation of charges A. So I'll write PA is equal to QA. What about P2? It will be same because separation is A. We have equal magnitude is equal to 0. That is QA. Now, who will tell me this angle theta? If it is an equilateral triangle, this theta will be what? 60 degree. So this theta is 60 degree, which means we have 60 degree angle between this dipole and this dipole. So what will be the direction of the resultant dipole? It will be, due to symmetry, I can say that the direction of the resultant dipole will be in this side. Now, what will be the magnitude? So if these two are same, then I can say this is 30 degree and this is 30 degree. Okay. The component of P2 in the direction of the 30 degree left hand side, what will be that? It will be P2 cos theta. Theta is what? 30. Okay. Component of P1 in this direction is P1 cos 30. What about the other component? For the P1, I'll have P1 sin theta, sin 30. For P2, I will have P2 sin 30. Can I cancel these two out? Why? Because P1 is equal to P2 and sin 30 is equal to sin 30. So I can simply cancel out these two. So what will be my resultant moment? The resultant moment will be P2 cos theta plus P1 cos theta. This P2 plus P1 is equal to P, which is equal to QA. So it will be QA cos 30, 2 times QA cos 30. What is the value of cos 30? Root 3 by 2. So my P vector will be root 3 QA. Any problem till now? Root 3 QA. Clear? Very good. Very good. Let's do one more question then. Let us say this time I have a square and I have placed minus 2q plus q plus q minus 2q. What will be the dipole moment here, given that the side of the square is A? What will be the dipole moment? It is very easy. You can answer it within the fraction of seconds. Why? Because it will be 0. Why? Why it will be 0? Let's see. Minus 2q, minus q, minus q. This will be a dipole. This will be a dipole. Okay, minus 2q. So minus q, minus q. This will be a dipole and this will be another dipole. So resultant of these two dipole will be in this direction. And what will be that? It will be root 2 QA. Okay, and resultant of these two dipoles will be in this direction, and that will be also root 2 QA. So the resultant of the dipole will be root 2 QA minus root 2 QA, which is 0. Any problem? All cancel out each other. Very good, very good. They all will cancel out each other. That is why the total dipole moment will be 0. Okay. Okay, have you studied the electric field due to electric dipole in the last chapter? Have you studied the electric field due to electric dipole? Yes. Then please tell me, at a coaxial point, what will be the electric field intensity due to an electric dipole? At a coaxial point P, what will be the electric field intensity due to an electric dipole? 2 kp by cube of x, cube of x, cube of r. Very good. It is 2 kp by r cube. Very good. Let's say if I have a point here, at the equatorial point, what will be the electric field intensity? Very good. It is in the direction of, its direction will be in the direction of electric dipole. But what can you say about this point, equatorial point? Anyone? It will be kq by r cube, not q, it is p. It is p vector, moment. It is kp by r cube. Okay, and the direction, what will be the direction? Its direction will be anti-parallel to the dipole moment's direction. What is anti-parallel? Anti-parallel means this direction. This much you know? Do you know this thing? Or do I need to explain it again? कोई है जिसे नहीं पता कि इलेक्ट्रिक फील्ड कैसे कैलकुलेट किया जाता है एक्सियल पॉइंट पे, कैसे इक्वेटोरियल पॉइंट पे, और एल्स I have a point somewhere here, let's say, any arbitrary point. Then what will be the electric potential, sorry, electric field? It will be Kp by R cube 3 cos square theta plus 1 root. Sir, I don't know. Okay. So should I know, should I tell you this thing, or this thing, or the whole thing? You don't know how to calculate electric field, right? Okay, let me tell you this. You know Coulomb's law, right? It is minus Q, it is plus Q. Let's say on the axial point, the distance is calculated from the center of the dipole. It is R. Let's say the separation of the dipole is 2a, which means A is here, making the distance is 2a. So, due to the Coulomb's law, what will be the electric field's direction at this point due to this positive Q? It will be this, and due to this negative Q, it will be this. Notice this, electric field due to this plus Q, मैंने ज़्यादा लंबा लिखा है. Why? ये इतना मैंने extend क्यों किया है? क्योंकि इसका magnitude ज़्यादा होगा. Why the magnitude of the electric field due to this charge will be greater than this charge? It is because the distance is less here. It is inversely proportional to R square. Okay. So here E2, it is even. So the net electric field will be E2 minus E1. E2 minus E1, but the direction of this net will be in the direction of E2 because ये ज़्यादा है. ये सिर्फ इतने को ही कैंसल आउट कर पाएगा, बाकी का डायरेक्शन तो इधर ही है ना. That's why E net का डायरेक्शन भी इसी डायरेक्शन में होगा. अब कैसे कैलकुलेट करेंगे E2? E2 किसकी वजह से है? इसकी वजह से है. So KQ by R square. KQ by R square. What is R here? What is R here? It is R minus A will give me this distance. If I say R minus A, it will be this distance. So it is R minus A. Again, negative. Due to this negative charge, the electric field will be KQ by R square. The R is calculated as R plus this A. So it will be KQ by R plus A. Okay. E net हम ऐसे कैलकुलेट करेंगे. KQ कॉमन आउट करें. KQ तो ये हो जाएगा R plus A minus R plus A divided by R square minus A square. R square minus A square. So it will be KQ. It will cancel out each other. I have 2A by R square minus A square. I have 2A by R square minus A square. I can say that this is very less than R. इफ इट इज वेरी 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 लेस देन, और मैं इसे इसके साथ ऐड करूं या सब्ट्रैक्ट करूं, आर पे कोई फर्क नहीं पड़ना चाहिए, नहीं पड़े, क्योंकि इट इज वेरी वेरी लेस. So I can neglect this term because it is very less. We have seen these dipoles are at the molecular level. So at the molecular level, the distance is very less. Okay. So KQ 2A by R square. Okay. Very good. So what is this Q into 2A? What is Q into 2A? It is P vector. So ये हो जाएगा KP by R square. Sorry, कुछ गड़बड़ हुआ है. E2 minus E1. What is electric field intensity? Okay, it is square here. R square. So if R square is here, it will be R square minus A squares square. So the next expression will be, if I'll cancel out this, it will be R to the power 4. So if it is R to the power 4, I can say that the R should be cancelled out here. So it will be what? Square square, so it will be 4AR. It will be 4AR here. So 2 I can, so it is 2AR here. R से ये R to the power 4 कट होगा, so ये R cube आएगा. So now the result will be 2KQ divided by R cube. Okay, फॉर्मूला में स्क्वायर होता है, KQ डिवाइडेड बाय R स्क्वायर. सो ऐसा करेंगे तो ये R स्क्वायर प्लस A स्क्वायर प्लस 2AR माइनस ऑफ R स्क्वायर प्लस A स्क्वायर माइनस 2AR, दोनों कैंसिल आउट होंगे. R स्क्वायर और A स्क्वायर बचेगा क्या? 4AR. 4AR में से मैंने 2 को बाहर ले लिया और 2AR मैंने अंदर रहने दिया. तो A स्क्वायर में कैंसिल आउट करूंगा, R टू द पावर 4 आएगा. इस R से ये R कैंसिल आउट होगा, R क्यूब होगा, which means I will get the expression 2KQ by R cube. Any problem in this expression? Is it clear? How do we find the electric field at the axial position? Very good. Now let's say the electric field at the equatorial position. Electric field at the equatorial position क्या हो जाएगा? It is minus Q, it is plus Q. At the equatorial point P, let's say it is X, it is Y. So the direction of electric field will be what? Due to this plus Q, it is away. Due to this minus Q, it is along. So the magnitude will be same. So the resultant will be anti-parallel. That's what I was talking about. कि इक्वेटोरियल प्लेन में अगर कहीं भी आपके पॉइंट पे इलेक्ट्रिक फील्ड इंटेंसिटी फाइंड आउट करना है तो उसका डायरेक्शन आपके डाइपोल मोमेंट की डायरेक्शन के एंटी पैरेलल होता है. क्यों होता है? इस वजह से होता है. लेट्स से दिस इज थीटा. ओके, सो if it is A, it is R. What will be the distance of Y and X? X will be root A square plus R square, and this Y will be root A square plus R square. Due to Pythagoras theorem, we can say that this distance will be root A square plus R square. Okay, now what about the electric field here? The electric field, let's say due to this charge I have E1, and due to this charge I have E2. So let us calculate E1. What will be the E1 here? E1 will be, the distance is root A square plus R square, so KQ divided by root A square plus R squares whole square. Okay, now E2 will be what? E2 will be same because the distance is same, root a square plus r square. KQ divided by square of root a square plus r square. Now, let us say I have, if this is theta, this is also theta. So I can say in this direction it will be E2 cos theta. And this is theta, this is also theta. Okay, because of this is theta, and because of this alternate angle, this is theta. So E1 cos theta. E1 cos theta. E1 and E2 मैग्नीट्यूड में सेम है और थीटा भी सेम है, which means E1 और E2 सेम होगा ना. ओके, सो इफ दे आर, और ये होगा कितना, if it is theta, it is theta. I need to find out the total resultant of the electric field. Okay, I guess the time is up. Okay, we'll see the electric field in the next class, and it will be KQ divided by RQ, anti-parallel to the electric dipole. We have many things afterwards. So thank you so much.